Okay, so today we are in topic 8, block 2 of inequations and inequalities. And we are going to be analyzing situations involving linear relationships and formulate linear equations to solve problems. We're going to solve equations in the form of px plus q equals r. And we're going to determine if a value is a solution to an equation or inequality and interpret the solution for given context. So, if you think about what we did yesterday in Khan Academy, we basically met every one of these objectives yesterday in Khan Academy. So, the whole purpose of that was so that we would be prepared for what we're doing. So, today, what I want us to think about is I want us to kind of think back to the Crabco family. Okay. Now, today, we're going to be looking at a new family. This is the Sabco family. All right. Or Sabco, however you want to say it. So, what part of the Sabco body is growing?
The middle.
Yeah, the middle of their body's growing. That's correct. What part's not changing?
The bottom and the top.
Yeah, so like their hands and their, I don't know what you would call that, the top of their head, maybe?
Antennas.
Or maybe they're, yeah, sounds good to me. So, looking at this, read what that says for us, Isaiah, and tell us what it says about the family members.
In the overview, you absorb the crab codes and how they grow. Now play the animation to analyze the Sabco alien family as they grow.
What's it say about the family members?
Family members number 1 have 2 body selections and 3 hair legs. Family member 2 has 4 body selections and 3 legs. Family member 3 has 6 selections and 3 legs. Which is the same of each family member? What is different?
All right. So, what's always staying the same?
The legs.
Yeah, the 3 legs. They all have 3 legs. The only thing that's changing is their what?
The body section.
The body section. The body section's growing how much each time?
3. Oh, I mean,
Say it again.
1 and 2.
Yeah. So it went from 2 to 4 to 6, right? So each time it went up by how much?
2.
Okay. So it says, what can help organize the data for the family member number and the total body parts? What could we use to organize that data?
A number line?
Yeah, number line might work. What about like a table or a chart? Would that help?
Yes.
All right. Let's take a look and see what they chose. Okay, so they used a table. And so it's showing that if there's one family member, to get the total body parts, I said that funny, to get the total body parts, they did one family member times 2 body parts plus the 3 legs. And then so the next one, what did they do? What's the only thing that's changing in that process each time?
What they time?
The family member is the only thing that's changing. So you'll notice that the family member is multiplied by the 2 body parts in the original Sabco, and then they have to add the 3 legs each time. So no matter how many family members there are, you're always going to take that number of family member and multiply it by what number?
2.
By 2, and then you add what? What's always left?
3.
Yeah, your 3 legs.
3.
And that'll give you your total body parts. So look what it says down there for our rule to Chandrik. What's it give us for our rule about the Sabco family?
Sapco family body parts follow the rule 2x plus 3 equals y. What does family member number 5 look like?
All right. So, what does question 1 in our workbook say?
Analyze the Sapco alien family. What is the same in each family member and what is different?
All right. So, we said what's the same? What did we say was the same? The legs. What did we say changed? The body section. Good. What does question 1b ask?
Sketch Sapco family members number 5. Sketch it next to the family members 1 and 2 above.
All right. So if you have not sketched him, I want you to try to sketch him. So think about this. What would family member number 5 look like in the body section area?
It would have 3 rows of body in between. No, it would have 5 rows.
Okay. So explain.
Each family member.
Let's try to draw it. So this one right here, 3 has 1, 2, and then his face, right? So that's kind of like 3. This one's got 1, 2, and this one's just got 1, right? So after I draw this, look like some Isamian's drawings. You hear me, Isamian? I'm messing with you. I know you draw way better than this. All right, so when we look at this, this is the.
I have no words for
that. All right, so how many parts will we put here in the center? This is 1. What would I need to do next?
Put 2 more.
All right. So that's the same right now. That's the same as 3.
That's why you gotta add 2 more blocks.
There you go. So we got 1, 2, 3, 4. It does kind of look like he's sad. He weighs too much. All right. So what else is that it, or do I need to add some more, or what?
That's 2.
Add 2 more?
I guess but it's more than number 3.
Yeah, it's gonna be more than number 3.
Ooh, the boy fat.
He's ugly, that's for sure. He kind of looks like a weird shrimp. All right, so let's take a look at it and let's make sure it's right. So we need to put a 5 in for what?
X.
For x. And so we're going to multiply it by 2 and then add 3. So what's 5 times 2?
10.
What's 10 plus 3?
13.
All right, let's see if we got the right number of body parts. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Does that look right?
Yes, sir.
All right. What do you think, Isaiah? That looks good?
Yes, sir.
All right. What about my drawing?
Oh, yeah, Mr. Mar, you're a real artist.
Thank you. Thank you.
I ain't got no words for that.
Thank you. All right. So if you have not created your little creature on part 1B, Make sure you do that now. Now for panel 2, that's the one that we're on right now. We're supposed to answer question 1C. All right. So on 1C, how does the algebraic rule 2 times x plus 3 equal y relate to this table? How does it relate to this table? The 2x plus 3 equals y.
Because that's the formula
It,
find out
keep going. You're right. It is the formula.
to find out how many body parts to give them.
All right. And so what are we always going to do for the letter x?
Put the family member's number.
Correct. And if we know that, can we always find out the total body parts that are going to be in the Sabco family?
Yes.
Yeah. All right. So is that what our person looked like? Kind of. Mine looked a little bit better than theirs, but they did okay. Does that look similar? Did we solve it the same as they did? Looking for a yes or no?
Yes.
Okay, good. Y'all are kind of dead acting today. Stay with me. We're almost done. Not really, but we're halfway. All right. So, looking at this, we said that family member number 5 had how many total body parts?
13.
13. And it says we could use the table or we could use the algebraic rule to show this. Now, we didn't use the table, but we did use the what?
Algebraic rule.
Good. All right. So, we're going to go ahead and look at panel number 4 and play it, and we'll be able to answer question 1, letter D, from it. So it says we can also see how the pattern in the table can be represented with a graph. So I want you to pay close attention to how they're graphing this. What's taking place each time? We go to our x and then we go up to our what?
Y.
Our y. Now, if we were to take a line and connect those dots, what would we have?
A non-proportional relationship.
Correct. It looks like a straight line, but it doesn't pass through what?
The origin.
The origin. Okay. Anybody have a question about that? So right now you need to create your graph on question 1D. I want y'all to do that right now. I'm going to give you about 3 minutes to do that. Haley, you need any more time to create your graph, or you got it?
I got it.
Anybody else need any more time? Najayla, you got yours?
I got it.
All right. I'm going to base it off of Haley and Najayla today. So everybody should have been able to complete their graph by now based off of Haley and Najayla's work, okay? Here we go. Let's take a look at part 5. So just like we said, if we were to connect that, it says the lines passing through the points. This represents the algebraic rule that 2x plus 3 equals y. And it says the line makes the pattern in the graph easier to see. Is that true? Is it easier to see to y'all?
Yes.
Okay. So what we're going to do with this is that I want you to think about what values of x make sense for this situation. Could I have a family member number 2.5?
Yes.
Okay. Explain.
Well, I mean, you would multiply it like normal, and you'd have half a block.
Okay. I can see how that would work. So, do y'all see any pattern that happens when the sabcos get larger? What happens as they grow? Every time the family member goes up just by one family member, what happens to the total body parts?
It goes up by 2.
Mm-hmm. Great. All right. So, what we're going to do is we're going to take a look at page 2, and this will be helpful for us to answer question 2 in our workbook. All right. Would you read that for us, please, Najayla?
You discovered that the Sabaco family's growth pattern followed the rule 2x plus 3 equals y. Now you can solve the puzzle to answer some equations about the Sabaco family.
All right. So, what would we do? It says which family member has 13 total body parts? Do we know that?
Yes.
Okay. How many total? So, which family member had 13 total body parts?
Number 5.
Okay. Good.
Number 5.
Great. So that next question says how many total parts will Sabco family member number 10 have? How would we find that answer?
13 times 2. Plus 3.
Repeat? I know plus 3. If we remember, we're going to use this formula right here. So what would we do?
Yeah. 10 times 2.
Good. What is 10 times 2 or 2 times 10?
20.
What would I do next?
20 plus 3.
Which is?
23.
Good. All right, so what I want y'all to do, it says write the equation for Sabco family member number 7. I want you to take about 30 seconds to see what you would come up with, and I'm going to call on a couple of people to help me out with that, okay? Okay, Jacaden. Jacaden, are you there? Looks like Jacaden might be absent. Let's see who else we got. Try to call on some. Wait, Jacaden's talking. Jacaden, what did you come up with? What would you put in for C? What letter? Or what number would you put in for C?
17.
Maybe 17?
But I thought what D would be 17 because I don't have a book.
Okay. So D, yes, I can see. Does that make sense to y'all? Does D sound like it would be 17? Am I getting a head nod? All right, cool. All right, so what would we have to multiply by 2 and add to 3 to get 17? What do you think, Samantha? What would we put in for letter C? Or Deonti? What would we put in for letter C?
I'm thinking about it.
Okay. Help him out, Chandler. 14? 14 plus 3 would equal 17. So what would C have to be, Haley?
7.
Why?
Because 2 times 7 is 14, and then you add 3, and that gets 17.
Does that make sense to everybody?
Yes, sir.
All right, good deal. Great job. Great job explaining that. Now, Jayla, can you restate what she said, please?
She said that since 2 times 7 equals 14, you add 3, and that equals 17.
Great job. Great job. Chandler, does that make sense? What about Deonti? Does that sound good?
Yes.
All right, good deal. I'm gonna submit it and see if we get it right. I knew we would. So it says when you know the number of body parts, we're able to work backwards to figure out what we would need to do with the family member. All right. So let's take a look at number 3. All righty. Will you read this for us, Lainey?
Which part?
You used the table.
You use the table and graph to analyze the Sabco family. Graphing technology can help you study tables and graphs efficiently. You can use the built-in graphing calculator by clicking on the calculator icon at the top of the page. Play the animation to see how it works.
All right. So what are we going to do? What's it tell us to do first?
The equation.
All right, so we're going to type this in here. That's a pretty neat calculator, huh? So it created a table for us, and it shows us what it looks like going through the X and Y axis, right? So take a look at what that says down there at the bottom. Will you read that for us, Layla?
By typing in the equation and selecting the table from the settings, you can see the relationship y equals 2x plus 3 in table and graph form. The x values represent the family member, and the y values tell you how many body parts the family member has. Note that while the graph and table show all the values and make the equation true, only whole number represent the sab since they can't have negative or fractional family members.
All right. So earlier we were kind of talking, and Emma was like, "Well, I guess if we did the 2.5, you could have like a half of a body part." Well, if we're thinking about like us, we could say like our arms would grow half half the length they are now, get a little bit longer, in other words. But this is saying that you can't really have 2.5 of a family member, can you? You'd either have three family members or you'd have two family members, right? So that's where this is coming from. And that's kind of how that ties into earlier. Does anybody have a question about this page on page number 3? So we were supposed to find the answer to the question number 3. We're trying to figure out which family member has 19 body parts using this graph. So how could we do that?
Fill it in all the way up to 5 and then just keep going up by 2.
Okay. So we're getting pretty close. It says that the fifth member has 13 body parts because 13 equals 2 times 5 plus 3. So we know that we're looking for the one that has 19. So that would be 19 equals 2 times some number plus 3, right?
Yeah.
What's 19 minus 3?
16.
What's 16 divided by 2?
8.
Okay. Let's see if that's pretty close to what it might be. Did that end up being right?
Yes.
All right, so let's take a look at what we just did. We actually just solved this equation. So what we did was we got 2x by itself. We did that by subtracting 3 and making 0. So we subtracted 3 here, and we got 16 equals 2 times x. And so to get x by itself, we undid multiplying by 2 by dividing by 2. And we know that 2 divided by 2 is 1, and 1 times x is x. And if we do something to one side of an equation, we have to do it to the other side. And 16 divided by 2 was 8. And so that's exactly what they tell us here. That would be family member number 8 that has 19 body parts. What do y'all think about that? Is it easier to use the graphing calculator or just solve it?
Just solve it.
Okay. I think some people are probably going to say if you have the graphing calculator, it's easier to just use the graphing calculator. But once you know how to solve an algebraic problem, it's actually pretty quick. And that way you don't have to be searching all through the calculator trying to find your answer.
We'll just use our
That works too. So explain what you did.
So I filled it in up to 5 because we knew, well, we knew when 2, 3, and 5, but I just used the pattern filled up 4. So I got to 5, and then I just kept going up by 2 because that's the pattern.
I got you. So it was like 5 was to 13, so 6 would have been to what?
15,
And then 7 was,
17,
and 8 would have been what?
19.
So that's how you did it, right? Does that make sense to everybody how Emma was able to do that? All right, I'm getting some thumbs up. Good deal. Good job, Emma. All right, let's take a look at this. Jamal, will you read this? I think Jamal shot out. Let's get someone else. Emma, why don't you read this for us?
You can also use physical models to solve equations and answer questions about the Sopko family. Play the animation to explore using a balance scale to help you solve equations. Then use a scale to figure out which Sopko family member will have 15 total body parts. You can think of an equation as a balance scale. Both sides of the equation must total the same quantity. For example, 5 equals 2 plus 3 can be modeled as 5 blocks weighing the same as 2 and 3 blocks.
Okay. So it says using a container to represent an unknown value is convenient way to model many equations. Suppose each yellow cube weighs 1 unit. The blue cylinder is a container that holds an unknown number of cubes. So imagine that the container itself has no weight at all and does not impact the scale. So this says that 4 equals 1 plus x. So what would x have to be in order to make this scale balance out?
3.
Why?
Because 1 plus 3 equals 4, and 4 blocks are on the other side.
Great job. Do y'all agree with what he said?
Yes.
Good, good. So it says examine the scale. On the left, there are 4 cubes weighing a total of 4 units. And on the right side is 1 cube and the blue container with an unknown number of cubes inside of it. The scales balance, so both sides must be the same weight. So the equation represents the same relationship. So how many cubes were in the container? We said that there were how many cubes in the container? 3. Good. So take a look at how they solve this. What are they doing to both sides? What are they trying to do?
Even them out.
Yeah, they're trying to even them out and they're trying to get that x all by its what?
Self.
All by itself. And
So,
soon y'all will hear me say, they're trying to isolate the variable. That means that they're trying to get x all alone. And so we've talked about it in class before, and we've said that to get x by itself, we have to do what?
do the opposite.
Yeah, do the opposite. We're undoing what's being performed to that x. And in this case, what was happening to the x?
So it was being subtracted.
Look at it at the beginning. What's happening right here?
It's being added.
That's right. 1 is being added to x. So in order to solve this, what did they have to do?
Change the sign.
Well, they kind of sort of. So really what they're doing is they're undoing x plus 1 and making it 1 minus 1 so that this equals 0 so that you're able to have x all by itself. But if we do something to one side and we want this scale to say perfectly level, then we have to do it to this side as well. And whenever we do that, we're able to find out that x is equal to what? 3. Okay, so this is basically exactly what we said a while ago. We said that the scales balance. We know both sides have to be equal. It says the scale shows that the container on the right has the same weight as the 3 cubes. So how many cubes have to be in the container?
3.
Yeah. So it says that we're using this container to represent an unknown quantity of cubes inside of it. But we know that we also use variables, which are letters that are used in math to represent an unknown value or unknown quantity. Okay. So let's take a look at this one. Read what that says for us, Haley.
Sir?
Read this for us, please, ma'am.
Think about this problem. The two blue containers each have the same number of cubes. The scale is balanced, so both sides weigh the same. Find out how many cubes are in each blue container.
All right. So what would we do to figure this out?
Subtract.
All right. What would we subtract?
3 from 15.
Good. And when we do that, what would we be left with?
12.
Okay. And then so we would have two x's equal 12, right? So how would we find out what would be inside these two containers?
Divide 12 by 2.
Okay. Do y'all agree with what Emma said?
Yes, sir.
Yeah, that sounds good. So when we get to this part, we're going to divide by 2, just like Emma said. And so that means that x has to be what?
6.
Yeah, 6. All right. So that is our answer. So it says we're left with the container x on the left side and 6 units on the right side, and the scale's balanced. So therefore, there must be 6 cubes in the container. So the Sabco family member number 6 would have how many body parts?
12.
Well, his body section would be 12, but he also has his 3 legs, right?
Yes.
So 12 plus 3 would be
15.
good. Good deal. All right, let's take a look at this animation real quick. So remember the Sabco family has family members. We use the 2x plus 3 equals y. And so we're trying to figure out which family member has 27 body parts. So we're going to solve for x by adding or dragging away blocks. And we're going to remember that we always have to keep the scales balanced. So it says that the scale has braces on it that's going to prevent us from seeing whether the scales are balanced. So if we want help, we got to click to remove those braces so that we know we're doing the right thing. So if you would, Isamian, why don't you tell us what to do? What would you do, Isamian? All right. Somebody help him out. Isamian said he can't do that right now.
I'm back because I had somebody blasting music.
I got you. I got you. So what we're trying to do is even out this. Tell me what I would need to do on both sides so that we can figure out which family member has 27 total body parts.
It depends how many cubes are in the cups.
Correct. So how can we, what's the first thing we could try to do so that we could just have the containers there alone?
Evenly split out the cubes into the cups. I don't see how we're going to be able to do that.
I see, I can kind of follow what you're saying. Who can help Isamian out? What could we do with those 3 blocks that are on the left side? Come on, my guys and girls. We got 15 people in here. We can figure this out. You are more than welcome to work together. What could we do with those 3 yellow blocks? Emma just gave us a perfect example of what to do. Yeah, we're just going to take them away. What? There we go. I don't know why it keeps doing that. What in the world? I don't want y'all. Did I get rid of 3 on this side or just 2?
Just 2.
All right, let's get rid of 1 more. All right, so now it says divide into how many groups? How many groups are there?
2.
Okay.
2.
So when we do that, what's X going to end up being?
12.
Does that make sense to everyone?
Yes, sir.
All right, so if we do 2 times 12, we get 14, and 14 plus 3 is? No, that is not right. I'm trying to mess with y'all to see if y'all can catch me. 2 times 12 is what?
24.
24. And 24 plus 3 is?
27.
Perfect. All right, let's take a look at this. Now, before we get too far, what I want us to try to figure out on this page is, can there be a family member with an even number of body parts? Or will they always have an odd number of body parts?
It's always going to be odd.
Why?
I don't know. I just went through that chart we made a long time ago. And
That makes sense. All right, so we started off with an odd number, right? So every time we add 2 to an odd number, we always get a what? An odd number. Is that kind of what's happening? All right, so I want you to think about it. And we're going to go through this and see if what we're predicting is true or not. So it says Sabco family member number 12 has 27 body parts. Can there be a family member with an even number of body parts? And we kind of said no, is what we're thinking, because we started off with 5, and if you add 2 to it, that would be 7. If you add 2 to that, that's 9. You add 2 to that, that's 11. You add 2 to that, that's going to be 13. So each time you're always getting an odd, is what we're saying. So if you would read that for us, please, Isamian. No, there cannot be such a family member. All family members have 3 legs and an even number of body sections. So an even number plus 3 will always be an odd number. So the total number of body parts for any family member is always an odd number. Now, we looked at it a little bit differently than they did, but in both cases, what do you always end up with? An odd number. Good.
Unless you want to hear this chaos in my background, then okay.
It's all good, man. I'm used to it. And the jailer's really loud too. I just roll with it. All right. So looking at this one right here, Chandler, would you read that, please, sir?
You have solved equations using a balanced scale and the subtraction property of equality. Now practice solving other equations using a balanced scale and the addition property of equality.
All right. So what do you think? Do you think it's going to be helpful?
I did not mean to raise my hand. I accidentally pressed it.
That's okay. Do y'all think it'll be helpful?
No.
I have no idea. Let's see. It says you cannot use the subtraction property of equality here because we don't have any positive number 1 blocks on the right-hand side to remove. So what we can do is focus on what I've always said. We want to get 2x by itself first. So to get 2x by itself first, what do we have to do?
Subtract.
Correct. So we're going to get rid of that 5, and that's going to give me what?
-3.
All right. So I got 2x would equal -3. But if I get rid of this and I move them all over here to even this out, that means I'm putting that -5 here. And so if I add those together, -3 plus -5 would be negative what?
8.
Correct. So when we get that, we get 2x would be equal to -8. And just like we solved earlier, this is 2 times x. So to undo 2 times x, we would
Divide.
Great job. And when we divide, we get x would be equal to what?
4.
4. Would it be positive or negative?
Negative.
A negative. Good job. All right, let's see what happens when they do it. See if it's the same as what we just did. So it says they're making a 0 pair. That's exactly what we did. And so when they did that, they put those over there. And so that's how many negatives on that right side? 8. And so what do you think they're going to do? Do you think they're going to do exactly what we did? Do you think they're going to split that into 2 groups? And when they do, what they end up with?
-4.
Good. -4. So how are y'all starting to feel about what we've been doing in class? Are you starting to feel pretty comfortable? Or not yet? Getting better?
It's getting more easier.
Good. Good. All right. So what we're going to do is we're going to get an equation. And I want y'all to work together to solve this. So I want y'all to talk it out and tell me how to model it on the screen. So far, I've had Emma, Najela, Haley, and Chandler, and Izamian. They've all been kind of taking control of the class. So I need some of my other people to step up, okay? We got multiple people in here. Tashandrick, Sarah, Miranda, Layla, Lena, Jemiah, Jake, Hayden, Deonti, Chris. Y'all can all step up too and add to this. You don't have to be scared. If you get something wrong, that's okay. I get stuff wrong sometimes. We're not all perfect. Man, I felt like that was a great motivational speech and nobody is helping. I'm always going to have to rely on my 5 people, I guess.
Do we do 3 of those, the X?
Woohoo! I'm just glad you're talking to me, Laney. All right, so she said, let's do 3 of the X's. All right, let's do that.
And let's add like 4 of like those ones of like the squares.
Okay. Good job, Sarah. Y'all making me happy. All right. Now what would we do? We got our left side. What would we need to do to our right side?
The 3.
Well, we got our 3 X's.
So 4.
Yeah, we got our 4 ones right here. So the left side of the scale, it's done, isn't it? So what do we need to do to the right side? So right now, let me show you what I'm saying. Y'all have done this. Y'all put this right here. So what needs to go over here?
7.
Yeah.
And yellow.
Yeah. Does that make sense? Or is that confusing?
At first I was confused.
I'm going to be honest. I've never done this before, so we're just shooting for the best. Look at that. Knew it had to be right because look, we got 3x plus 4 on the left side and we got 7 on the right side, right? So it says now solve for x by adding or dragging away blocks or balloons. Remember to keep the scales balanced, so you have to do the same thing to each side. So what are we going to do with this 4 on the left side? What do we have to do? So that we can get our 3 x's by themselves. What do we need to do? Yeah, we just got to I just subtract by 4. Subtract by 4. What's 7 minus 4?
3.
Yes. So we're taking away our 4 here. So if we take away 4 on this side, we have to take away 4 on this side. So now we got to divide it into our groups. Right? It's easier for me to just do it on the equations. Sorry, I had y'all thinking crazy a while ago. All right. So when we take away the 4 on each side, what do we put into each one of these?
1.
1. Correct. All right, let's try another one. So on this one, let's set it up. We got what equals 5x minus 5?
10.
All right, so we're going to pull how many?
10.
Okay. And then what would I have on the other side? How many of these?
5.
Good. All right. And then what else would I need?
5 units.
Good. Okay. So it says to solve it. So let's check our model and then we'll solve it. So what would I need to do so that this is gone and 5x is by itself?
Subtract.
Well, we're already subtracting.
Add.
There we go. We're going to add 5. So this would be 0 on the right side. And then we would have to bring those 5 over here. So this becomes what?
15.
Correct. So we're taking these away. They're coming here. And then we got to divide it into how many groups?
5.
Good. And so what's our answer going to be?
5.
You sure?
No.
3, because 15 divided by 5 is 3. Is that making sense to everybody?
Yes, sir.
All right. So why is the number of body parts always odd? What did we say earlier?
Because you can't add. Because we started off with an even odd number.
All right. And so since there's an even number of body parts and we add 3 to each even number of body parts, it's always going to be what? Odd. Can we use a balance scale to represent equations with like fractions or decimals? Do you think we'd be able to do that?
Yes.
Yeah. I think we're going to get into that very soon. So what I want you to do today is I want you to complete questions 9 and 10 in your workbook, parts A and B. And I would also like you to take a little time and try to use this and answer these two using this scale model, okay? So I want you to try to do that on your own. So that's on modeling and solving linear equations on page 8. So I hope y'all all have a fabulous day, and I will see y'all here tomorrow.